All right, let's look at the derivatives of inverse trig functions. All right, so we have 6 of these, the derivative each inverse trig functions, and the most popular ones are usually these two, number 1 and number 3. So the proof of these are very similar to each other, so I'm going to just do the proof of those two and using the implicit differentiation. All right, so let's go through this. All right, so we want to find, I'm going to let f of x, let's do the proof of number 1. All right, I'm going to call this guy, actually, I'm going to call y, sorry. All right, so y is equal to, all right, arcsin of x. Right? Then what we want to do is we want to find y prime, right? So we're looking for y prime. So since we don't know how to take the derivative of inverse trig function right now, so I'm going to apply sine to both sides to rewrite it using a regular sign. So this is the equivalent to sine of y is equal to x, right? Because it's an inverse function, goes backward. All right, then we can take the derivative. So I'm going to take the derivative with respect to x. All right, derivative sine is cosine, and y, then you have to multiply by derivative of the inside function. So we can put the dy over dx or y prime. Since I use y prime here, I'm going to use y prime. So this is just a chain rule. All right, derivative of x is obviously 1. All right, since we're looking for y prime, all you have to do is isolate that. So I'm going to divide through by cosine of y. All right, so it's a y prime is equal to 1 over cosine of y. All right, then all you have to do is rewrite it to what we have here. All right, so remember that here you have sine of y, so cosine of y is really square root of, using a trig identity, 1 minus sine squared of y, right? So which means that this is just a square root of 1 minus, right? I've seen sine of y is equal to x, so x squared, right? So this is actually the same thing as 1 over square root of 1 minus x squared, right? So a little trig identity allows you to rewrite it to what we want. All right, so we verified number 1. All right, so let's verify number 3. Right, so arctangent. So trig is actually exactly the same, so it's almost boring. So we let y equals arctangent of x, right? Then we're looking for, again, y prime. So first thing is, since we don't know how to deal with arctangent, we're going to rewrite it by applying a tangent to both sides. So you have a tangent of y is equal to x. Right? Then we can take the derivative from there. So we take the derivative with respect to x. Right, derivative of tangent is secant squared, so you have secant squared of y, but you have to do the chain rule, multiply by derivative inside. And derivative of x is again 1. Right, then we can divide through by secant squared of y. So we have y prime is equal to 1 over secant squared of y. All right, so remember that the trig identity is secant squared of y is 1 plus tangent squared of y. So that was that's one of the trig identity. And we know that the x is a tangent of y. So this is just going to be 1 plus x squared. All right, so this becomes 1 over 1 plus x squared. So that's what we have for number 3. right? All the other ones can be proven by a similar method. So I'm not going to go through that. But the most popular one that shows up quite often is number 1 and number 3. All right, that's it. I hope that this was clear.